Download this code and get free GPT-4o from codegive.com, link in the description below. Transpiling code from Java to C++ can be an involved process since both languages have different paradigms, libraries, and runtime environments. However, a Java to C++ transpiler can help automate some of this process. This tutorial will cover the basic concepts of converting Java code into C++ code, along with an example. Overview of Java and C++. 1. Syntax differences. Both languages have C-like syntax, but there are significant differences in data types, libraries, and memory management. 2. Object-oriented programming. Both languages support OOP, but Java is purely OOP, while C++ supports both procedural and OOP paradigms. 3. Memory management. Java has automatic garbage collection, while C++ requires manual memory management. 4. Libraries. Java has a rich set of libraries, Java Standard Library, whereas C++ has a different set, C++ Standard Library. Basic concepts to consider. Data types. Ensure correct mapping of data types. For example, int in Java maps to int in C++, but ArrayList in Java would typically become a std vector in C++. Control structures. Most control structures, if-else, loops, remain similar but check for specific syntax differences. Classes and objects. Convert Java classes to C++ classes, adjusting for constructors, destructors, and access modifiers. Packages and headers. Java packages need to be converted to C++ headers and namespaces. Exception handling. Java's try-catch blocks will need to be adapted to C++'s try-catch. Example Java code. Here's a simple Java program that demonstrates a class with methods. Transpiled C++ code. Here's how the above Java code can be translated into C++. Key transpilation steps explained. 1. Class declaration. Java's class calculator becomes class calculator in C++. 2. Method definitions. The method definitions are similar, but C++ doesn't require the public keyword for methods in the class unless specified otherwise. 3. Main method. In Java, the main method is static. In C++, main is a standalone function. Java's system.out.println is replaced by stdcode. 4. Memory management. Java manages memory automatically, while in C++, you would typically manage memory with new and delete. However, in this case, we use stack allocation which does not require manual management. Tips for building a transpiler. 1. Lexical analysis. Use tools like ANTLR to parse Java code into an abstract syntax tree, AST. 2. Transformation logic. Implement transformation rules based on the differences between Java and C++. 3. Output generation. Generate C++ code from the transformed AST. 4. Testing. Test the transpiled code to ensure it behaves as expected. Conclusion. Transpiling Java to C++ can be automated to some extent, but it requires careful consideration of language-specific features. The example provided shows a simple class conversion, but more complex features, like interface, generics, threading, etc., will require more sophisticated handling. Building a fully functional transpiler can be a challenging but rewarding task that can significantly ease the process of porting code between the two languages.